look at how to approximate the area under a curve. Now this is a lead into when we use our integrals to find the area under the curve. So these methods are obviously just approximating. We're not going to get an exact value. So to get an exact value of the area under the curve, we would have to use our integration. So I've got a little example here, and I'm going to show you the 3 different ways that we can find the area, approximate the area under the curve. So we can do the left rectangle, right rectangle, or trapezoidal. Now, the left and right may also be called like left endpoint and right endpoint method. Basically, we're making rectangles that we can then find the area of. So in the case that I've got here, the width of each of these gaps here is 1. So I can then draw in, so if I'm doing the left rectangle, I'm making a rectangle with that left endpoint. So say I'm going between 1 and 4. Then here is my little rectangle there. And I know that the area of that rectangle is going to be length times width, or length times width, which is going to be the 1.5 times 1. So I know that the area of that little rectangle is going to be 1.5. Then I can do the next one. So I would bring that line across. And I'm going to get, that comes up to 2.5. So 2.5 times 1 is going to give me 2.5. And then I've got this third one here. And that goes up to 4. So 4 times 1 is 4. So when I add that up, the 1.5 plus the 2.5 is going to give me 4, plus my 4 gives me a total of 8. Then if I look at the right rectangle, that means we're now not going left, we're going to take the right side, or the right endpoint, which means obviously we're going to get a different answer. So that means I'm bringing my rectangle instead over this way to make my rectangles. So then this time, when I work out my area, it goes up to 2.5 times 1, so I get 2.5. Then I've got 4 times 1 is 4, and 6 times 1 is 6. So then I'm going to get an answer of 12.5. So obviously that is a bigger number than the left end point or the left rectangle method. And that's why obviously those 2 methods are okay. The third method that you'll generally use is your trapezoidal, where rather than picking one of those points, it's like you're averaging them. So you're making it into a trapezium, these 2 points, and bringing a line down like that. And when we do a trapezium, we do the a plus b over 2 times the height. So you're averaging each of those. The easiest way I like to use the trapezium method is to kind of summarize it, where the area is approximately equal to the width over 2 of the ends plus 2 times the middles. Because when you are using that, you're only using, so that you would do the 1.5 plus the 2.5 divided by 2, then the 2.5 plus the 4 divided by 2, then the 4 plus 6 divided by 2. So you're using the middles twice, but the ends are only being used once. And you've got your width over 2, because when we do our averaging, that's where that over 2 bit comes. So in that case, for this scenario, we would be, so the points that we've got are the 1.5, 2.5, 4, and 6. So our ends are the 1.5 and the 6. Our width is 1, so we'll do a half outside of. Then we would have the 1.5 plus 6 plus 2.5 plus 4. And I need to times that by 2. And so I'll get 3.25 there when I do that. Oh, whoops. 2 times, sorry, try that again. 2.4 plus 6, and I'm going to times that by 2. So I get 16.8. So then I'm going to do the 1.5 plus the 6 plus the, let me just go back and check this. 2 times the middle is 2.5 plus 4 times 2 is 13. Third time lucky. So now I'm going to do my 1.5 plus the 6 plus the 13, and then I'm going to times that by a half, and so I get 10.5 as my approximation for my area. Now, this kind of makes sense, doesn't it? Because it's halfway between the 8 and the 12.5, and we get our 10.5. That's why the trapezoidal is usually the estimation of choice. But if you're working through textbook exercises, you will see them direct you to use either the left or the right rectangle or the trapezoidal. And there was quite a little interesting question based around this as a multi-choice one on an external paper a few years back, where it was asking which method would give you greater than, or like using one of the methods, would it give you greater than, less than, or this of the actual area. And you had to think about what your curve would look like and where those rectangles would fit. So it is an interesting one to think about and have an understanding of.